Welcome to CO2 Monday and the Refrigeration Mentor podcast. I'm your host, Trevor Matthews. And once again, I want to thank everyone for taking the time to invest in themselves, to really spend the time each week, either come into the Zoom sessions, listen to the podcast. Over the last 9 months, I've learned so much about CO2. And it's all because of the experts that come here, share their knowledge from the technicians to the manufacturers. Today, I have a returning guest, Giacomo Pisano from Dorin. And I am super excited about this conversation because I worked for a compressor manufacturer before and I've seen the rigorous tests they've done with their compressors. And I love learning more about this because I'm new to that stuff still, even though I've seen it. And it's exciting to see and the things that these manufacturers do to the compressors to make the best. And today we're going to be diving into the qualification testings for CO2 compressors. Giacomo, welcome to CO2 Mondays. How you doing?
Hey, Trevor. Hi, everyone. Thank you very much for hosting me today. And thanks, everybody, for attending. All good here. Hope the same with you. Hope you had a great 23 start.
Yeah, no, it's been amazing. Lots of cool things going on. Lots of CO2 conversations been had already. From our last conversation, we dove into the different types of technologies that Dorin has. We went through oil management, viscosity, which was really cool. Now we're adding on to that. Now we're about to add on to the things that really are important and what customers don't really know and manufacturers don't know and really technicians don't really know about what you guys do to make the best compressors out there, you know? I'd love to find out what it's all about.
Yes, absolutely. Actually, I'm very happy to share this information because I started in Dorin in 2003. So it's 20 years this year. And since from day one, I was working on CO2 transcritical application. My first task was actually I was an R&D engineer in the lab. And my first task was really to plan and rule out a design of experiment for qualifying our CO2 compressor range. So you can easily imagine that was really one-off, a very first time for this technology to be spread out. And it was real fun. It was real fun to have all those compressors running in the lab. I will go into detail, but let's say what is the scope of a qualification testing? Basically, we need to make sure that during the compressor lifetime in the field, the compressor will work as reliable and as efficient as possible throughout his lifetime. So what we have to do in our lab is to make a accelerated lifetime testing and basically try to kill the compressor and make sure it does not die. So that was the scope and we really well accomplished that.
That sounds like an awesome job, right? You're going in there to put everything you have against these compressors because compressors don't just die. And a lot of people, I've seen it time and time again. I've even done it. I've made compressors fail very quickly. The thing that we really need to focus on is understanding that we have to do a lot of punishment to kill a compressor. It's us out there as technicians that cause it. And you guys put them through these rigorous tests. And then you guys make like operation envelopes and characteristics. And you tell, don't go outside these envelopes, we'll say operation envelopes. But you guys build them for outside those envelopes, even though you guys do, well, we know that they'll work even past sometimes these envelopes, but we want to make sure that they'll last that 15, 20 years. But we consistently see compressors failing after 6 months, after 1 year, after even 6 or 7 years from the punishment that either the customers do to them, maintenance, or us as technicians do to them, or misapplied application as well.
Yeah, that's true. Honestly, of course, we also do mistakes. I don't want to say that we are perfect. Every now and then it happens that we have a problem ourselves. But in most of the cases is really something that is out from the compressor reasonable expected lifetime. Am I allowed to share my screen just to, well, few words about the company. We are headquartered in Florence, Italy. You are most welcome to come and visit us.
I'm going to.
Yes, beside the best compressors, clearly Florence is also a pretty city to see. So feel welcome to come and visit us. Very important to mention for the North American audience we have today, maybe not only North American, but also in the majority, I would say. We have Dorin USA up and running since 3 years now, and we have a new building in Tecumseh. That is our warehouse, and where we are going to have remanufacturing of compressors as well very soon. And yeah, feel also most welcome to come and pay a visit over there. In terms of timeline, I'm very proud to say that Dorin has been always at the forefront of CO2 transcritical technology. We have developed for first CO2 transcritical compressors. We have delivered almost 30 years ago the very first prototype of a semi-hermetic transcritical compressor to Sintef, which is a lab in Norway, where they had to validate basically the behavior of the back pressure valve in CO2, in modern CO2 refrigeration cycles. And then step by step, we have introduced into the market newer, more modern, larger, smaller compressors. And we actually have the largest transcritical compressor, which is UL approved. This is fully available in the market since years, and it's taking off in North America as well. So let's go a little bit deeper into CO2 design, CO2 compression design. So why do we have a challenge? This slide here is really self-explanatory in my opinion. This is one of my favorite, I would say. Have a look to the application envelope of 404A, 410A, and CO2 subcritical compressor, which are on the bottom left corner of this slide. You can see the green, red, and purple small envelope. And have a look on how they differ from CO2 transcritical compressors envelope. They are really two words apart. There cannot be any synergy between CO2 transcritical compressors and CO2 low temp or 404A or 410A. We have much higher differential pressures. We have much higher discharge temperatures. We have completely different oil management into the compressor. We have completely different solubility between CO2 and lubricant, vapor CO2 and liquid lubricant. So this brings in tremendous challenges that made us to design compressors from scratch. This is basically a summary of what we have been dealing about during the last episode. So what happens after we design our compressors? We have to test them. We have to test those compressors according to a specific qualification testing. And what we do is a kind of design freeze. What does it mean? We design the compressor and we freeze the design. We design the compressor and we say that according to our engineering knowledge, all the components are robust enough to tolerate the compressor operation, and the mechanical tolerance are tight enough to assure a proper efficiency. And then after we freeze the design of the compressor, we have to test it. And we have to do what we call qualification testing. So we have to qualify a specific platform according to certain criteria. Which are those criteria? Basically, we define the application envelope of the compressor, which is the blue line here. This chart has suction pressure in bar in the x-axis and discharge pressure in bar in the y-axis. So we define the maximum pressure ratio, which is the green line with pressure ratio 6 for CO2 transcritical compressor. We define the minimum pressure ratio, which is 1.5. We define the maximum current consumption, and we have our application envelope. The application envelope, by definition, is an area where the compressor will work safely throughout his lifetime. Our MTBF, mean time between failures, is between 50 and 55,000 hours, depending on the model. What do we have to do in order to prove that? We want to test the compressor in more challenging application. Clearly, we don't want to run a 55,000 hour test because it will be a business killer. We want to make it quicker. So what we do is to test out from the envelope. So we have selected 3 operating points, these red dots. This one over here is the maximum pressure ratio test. Maximum pressure ratio means suction pressure 188 psi, 1504 in the discharge. single stage compressor, not double stage, single stage compressor tested in low temperature, basically.
Well, it was like 8-to-1, I guess, pressure ratio around that.
Correct. Pressure ratio 8. Here we have the challenge of maximum discharge temperature up to 365 F discharge temperature.
Wow.
Then we have this point here, maximum differential pressure, 290 suction, 2030 discharge. And here we have maximum load. And then we have max load test with 870 PSI, 2030 PSI discharge. And here the challenge is maximum power input, maximum current draw, and also maximum oil dilution. In this condition here, oil is basically water. I mean, you have tons of CO2 inside.
Yeah.
And what do we do in these 3 points? We do continuous run test for 2000 hours, which is not a big deal, honestly, for the compressor, but it can give you a good indication of youth problem, youth design issues. So you have the compressor running for 2000 hours, very steady, no big deal.
So when you say that it runs for 2000 hours, is it one of the tests at a time? So you're doing one, say the max delta test for 2000 hours, and then would you take another compressor and do the max pressure ratio, or would you use the same compressor? Or
it's a complex matrix.
Okay.
Basically, we have assembled 20 design frozen compressors, and we have put them under testing. Depending on the matrix, maybe compressor from A to Z, they have done test from 1 to 6, but not all of them.
Yeah.
So it's a matrix. Yep.
But there are some points when you do all 3 of these tests, so you'd put that compressor through 6,000 of this rigorous hours.
Not necessarily. Let's say the compressor A that have done this continuous run test in this point, then this is performing another test afterward.
Okay. Yeah. Awesome.
And here comes the real fun. The real fun for compressor testing is short cycling and liquid return test. Short cycling means compressor run 2 seconds, stop 4, run 2 seconds, stop 4 for 200,000 times.
Wow.
Yep. And then liquid return is self-explanatory. We have the compressor running wet. So let's go a little bit more into details for those 3 testing. This is a picture of our lab. So you can see here we have 10 different test rigs all in a row. They are very simple. They are only gas cycle. So there is no evaporator. There is only a little gas cooler. So we are working in a triangle, basically. There is no evaporation. So this makes the system very compact, very repeatable, very easy to handle with a water loop that is cooling down CO2. So what we do here, this is a picture of the different test rigs. This is a picture of a liquid return test. How do we do liquid return test? Basically, we have been building a bleed line from the bottom of the receiver toward the suction of the compressor. This is clearly visible here. And how do these tests look like? Let me play a movie. So you will now see a typical short cycling test. Compressor is running 2 seconds, stopping 4, running 2 seconds, stopping 4. And this is this point over here, maximum pressure ratio. 13 bar suction, 104 discharge. Pressure ratio 8. Two-second run, 4-second stop. You see a lot of thermocouples, gas cooler. Now you see the pressure gauges. Action pressure, 13 bar, 180 psi. Discharge pressure 104 bar, 1400 psi, more than 1400. Single phase. On the electric panel, we have a counter to sum up all the cycles. So this was almost half of the test. 108,264, 65, 66, and so on.
Definitely impressive.
So only 1 point for one compressor in this condition is about 6 weeks testing.
Wow.
So it would be a little bit boring to have to look at a test for 6 weeks like
Yeah.
that, but
That's
that's
fair.
the way it works.
But that's why you have all the thermocouples on there, because you're measuring temperatures, you're logging so many other things, not only the start stops, but I'm sure there's so many other tests that you're doing, data you're collecting while it's doing
Right.
this.
Right. And actually, why is this test so challenging? Clearly, from a motor perspective, you are getting the inrush current very often. But beside that, you have to consider that the oil film is not there when you run the compressor for 2 seconds only. So you are testing the compressor against poor lubrication. So it is a very good way to do an accelerated lifetime testing.
Oh.
According to our algorithm and to our calculation, we see that this kind of matrix, so 3 operating points, continuous run, short cycling, and liquid return, are assuring enough confidence to have our MTBF target reached.
Yeah.
And this was short cycling, but let me also show you liquid return test. This is also extremely interesting. I will now play another video where we are running with liquid return, but it is not a liquid slug.
Yeah, it's 2 different things.
Completely different. Completely different. A liquid slug will kill the compressor very quick. But on CO2, by definition, the empty suction group, so the transcritical suction group, will be subject to heavy fluctuations in terms of suction temperature. And for sure, you will experience little superheat or wet operation. So where the quality will not assure you that you have 100% vapor at the compressor inlet. This is happening in any CO2 system. You can play in any way you want with the suction superheat, of course, unless you do not oversize your superheat, which doesn't make sense, also from an efficiency standpoint. But if your system is designed in a certain way, it will happen that, for instance, the LT load will be limited and the MT load is 100%. You will get a lot of flash gas, so you will have no superheat or wet operation. If you are at the commissioning, maybe not 100% of the load is in place, so your evaporator are not working properly, and you will get liquid into the compressor. It will happen. So we have decided to design our compressor in a way that are much more tolerant against wet operation. We have described that. We have described all the technical features we have implemented. Basically, we have taken a lot of ideas from combustion engines to tolerate poor lubrication. But now let's see how do we test it. Take a look at this pressure gauge. This pressure gauge is oil differential pressure. You will see that every time we have liquid return, this gauge is going down and then up, then is going down and then up. Why does this happen? Because basically, liquid CO2 is flashing away the oil film. So it really breaks the oil film. Liquid CO2 is a great cleaner, is a great detergent. So you will see foaming in the side glass, but the same foaming is happening in the drive gear. The same foaming is happening between the rod and the bearing and the shaft. So you flash away your oil film and you suffer from poor lubrication. Have a look. So you saw how many times this gauge went down because we were bringing liquid CO2 into the suction, into the compressor suction. So why do we do this kind of testing? Some of you may say we are over-engineering, but shit happens, we know.
Yeah.
And have a look to this movie. This is not a test. This is a real compressor operation in the field.
For those listening and not watching this, you're seeing the sight glass get very foamy. A frozen compressor.
Yep, this was not a test. This was real compressor operation. I was personally on site for 2 hours. All the MT suction group have been working that way. So it can be anything. It can be a wrong refrigerant charge. It can be a wrong setting for the metering device. Anything can be, but the compressor have been able to tolerate this operation for a couple of hours. I took note of the serial number of the compressor, and they never came back for inspection. So either they completely destroyed those, can be, or they fixed the problem on site. But for a couple of hours, the compressor was able to tolerate this operating condition, and it can make the difference in a job site, especially in industry. Every application is important, clearly, supermarket, but I'm thinking about a pharmaceutical processing system or a cold storage where you have a huge amount of money involved. Having your compressor capable to tolerate this behavior can make a big difference.
So these are some great points, and I didn't ask you on the other one, and maybe I could ask you after, but what are you looking for when you get the compressor back, or what is the technician maybe looking for when now the compressor's failed in the field from, say, flood back and the compressor is not running? Because that's really important for them to understand, or the failed from short cycling. What are some of the things that the technician out there should look for?
Let me first tell you what is our acceptance criteria of the qualification testing, because that's the real end of the story.
Yeah.
I mean, we do all this testing to have our compressor reliable enough, strong enough, durable enough, efficient enough. But what do we do after this test? After our qualification testing, what is our acceptance criteria? Basically, all the compressors we have in the market have run through this kind of testing before commercial launch. And after this test, the acceptance criteria is negligible wear. What does it mean? It means that before assembling the design frozen compressors, we take note of all the clearance, all the tolerances, then we run the test. And after the test, we tear down the compressor and measure again. And our acceptance criteria is negligible wear, which means that the mechanical parts of the drive gear are still within the tolerance. So we accept some wear, but the mechanical component must still be within the mechanical tolerance. And we have managed to fulfill that. So basically, the compressor, the Dorin compressors you find in the market are qualified according to this kind of testing. And after the test, we have found negligible wear in the main moving parts. So getting back to your question, what our technicians are looking into when we receive a compressor back from inspection. Basically, the major problem we see on CO2 are connected to lack of lubrication and are connected to liquid flood back and also to electrical problem, which is really not relevant to CO2. Very seldom we see issues with short cycling. So with compressor electrical failures due to short cycling, because honestly, the tests we have done are overtaking any possible scenario in the field.
Yeah, because the customer would hear that. They would come up, they would call their contractor like, man, it's been banging on and banging off for a day or two, you know? And like you're saying 6 weeks. So to get that many, so that just doesn't happen. I don't think anyway.
But the issues connected to short cycling, in our case, are more connected again to poor lubrication, because short cycling is an issue not only for the electric motor, but also for the drive gear, because the compressor should run enough time to have oil returning from the suction line. If this doesn't happen, then you will have oil sitting here and there, and the compressor may work with too little oil level into the sump.
That's all. It's because that's so important to understand, because there's so many dynamics of one issue that can happen causes two or three, like it's a compound effect.
Yeah.
And this is what I talk to a lot of people. Yeah, you might have one issue happening, but it's affecting two or three other things, either in the system or in the compressor. And so you need to take like a global look at what's going on at the system. And the biggest thing too that I try to tell every technician is that if you do have a failed compressor, you need to inspect it. You can't just pull it out, put it on. Well, you can. Sometimes you got to pull it out, put one in, but you got to inspect that compressor to figure out why it failed.
This is absolutely a key. Otherwise, you will have a series of failures, very likely. Yeah. If you don't see what was the root cause, then it is likely that you will have the same issue very soon.
Yeah, and another thing I say, refrigeration, it's all about facts. You get the temperatures, you get the pressures, you get the voltage, you get the amps. When you have all that information, then you got something to go off. But you can't just say, oh, it failed because it was worn out, or, oh, it's 10 years old, it was time to go. It just doesn't, it's not a thing. It's something caused that compressor to fail.
Yeah, it may have reached its end of life. It is a possibility, but this is also understandable only if you inspect the compressor and if you see a overall amount of wear in all the drive gear, then yes, it is plausible. But if you have broken reeds, that was not the issue, for instance.
Yeah, totally agree. So this is really cool to know that you run these compressors at countless punishment. And I really like that you went to a field site, and you say it was a couple hours running with wet liquid coming back or liquid returning. I'm sure it was running for a long time before that even you got there. You were only there for a couple hours. And what's amazing about that is the things that you can do if you have this issue is you fix the problem. Find that problem that's been happening in the system, like you said, and then remedy it. And the chances are that you're going to get a longer life out of that compressor and that system. And this is something you want to talk about with your customer as well. Let your customer know that the compressor was running outside its envelope, and it's a major issue, which reduced potentially the life of that compressor. You got to be honest with your customers. You got to talk to them so they understand when they have to spend a lot of money on replacing a compressor, and you want to be proactive. Good technicians are proactive. They work with their customers, especially in an industrial, and say, listen, we need to replace this compressor at this time when the process is down. If they're shutting down for a day or two, and this is when we got to do it. Be proactive. Reactive costs the customer way more money in the end. When you build that relationship with them and you do the proactive replacement, you're going to see a difference with your customers.
I do agree. Let me also tell you another thing. I mean, this is what happens prior to commercial launch. But what we do in our production line, I mean, we are manufacturing daily lots of compressors on CO2. What do we do prior to deliver? Clearly, we will not deliver those qualification testing compressors, obviously. But what do we do before we ship brand new compressors? This might also be interesting for the audience. So 100% of our compressors are leak tested with a 10% extra factor on the nameplate pressures. So this means we are leak testing all the compressor we manufacture at 110% of the nameplate data, which means 110 bar low pressure, 165 bar high pressure side for transcritical compressor, and 40 to 60 bar for subcritical compressors. The leak testing is done on all the compressor we manufacture, and this is done in a fully automated machine that works with helium. So basically, we connect the compressor to the helium line, with quick connection devices. We put the compressor into the machine, we close the chamber, we pull the vacuum outside the compressor, and we pressurize the compressor. And we have a leak detection machine, a leak detection instrument that is sensing helium. Why helium? Because it's a very fine particle, so it's very quick to have a leakage in case you have a leakage. So this is first test. Once the compressor have been passing successfully through the leak test, then we have the run-in test. 100% of the compressor we manufacture and we deliver are running a real CO2 transcritical test. Each single compressor we ship out is running a real transcritical test for about 20 minutes with 30 bar suction, 90 bar discharge, where we measure the mass flow, which is the real compressor performance. Compressor performance is not refrigeration capacity. Compressor performance is mass flow. Then mass flow times enthalpy is refrigeration capacity, but this is refrigerant properties, is not compressor. The compressor is displacing a mass flow, and this is his performance together with power consumption, clearly. Then we check oil pressure, clockwise and counterclockwise. Then we check motor insulation. 100% of the compressor are running a real transcritical cycle. We are the only manufacturer doing this kind of testing.
That's impressive.
We know it's a bottleneck. We know that very well. We know that very well. We have now 4 run test machines in our production facility. A 5th is in the pipeline so that our customers do not get upset in waiting for the compressors. No, that's not what we want. But running this test on, I don't know, 12,000, 13,000 compressor per year gives you an incredible amount of information. What is the oil pressure? What is the oil temperature? What are the discharge temperature, mass flow tolerance? It's huge amount of information we get out of it. And this helps us to improve day by day. It's a continuous learning process where we fine-tune our tolerances and our design, basically.
That's super awesome.
It's really an incredible amount of information we get out of it.
Yeah, I can just imagine. And it's a lot of work. And it's nice to see that you guys are putting that work in, because if somebody gets a compressor, it's been proven that it already ran. It already
Correct.
ran. So and this is what I've heard so many times, and I've even said it before, it's a dead on arrival compressor, or compressor don't work. The chances are so high. And even all the big manufacturers, and you're one of the big manufacturers, is that if you get a compressor as a technician, this is going to technician, and the compressor's not working, it's a lot of the time, it's either the manufacturer who designed that equipment had an issue with it, not the compressor manufacturer, or we did something as the technician before we got it up and running. Maybe not wired it properly, maybe not the right voltage. There could be the wrong size wire, contactors, there's so many different things. But the chances of having a DOA or a compressor that don't work right off the bat is very slim. And now that you know that they test every single one, that is amazing.
Right.
Wow. And so after that, what do you do when you guys get a compressor back? So I'm not sure. So you guys you send them out to the field. You do these testing, the qualification testing. You build it. You build an envelope. You put them through the test. You put them through your leak test, the motor test. You test run them. Then you send them out to the field. And just say something does happen within the first week, the first 6 months, maybe even the first year. What do you guys do at that point? Do you guys ask them to be returned so you can inspect them? Do you have the contractor themselves inspect them? What's your process for, say, a warranty or return policy, and how does that work?
Yep, let me show you what we have in place. Basically, what we have here, you can access that through the website. And we have this customer-service.dorin.com where you can register. You will get a password And in this way, you will be able to generate a own reporting for all the compressors you are about to shipping back to us. Because the first thing for us is to learn what happened. So here the customer will have a format where he will be able to punch in all the needed more interesting data like the compressor serial number and the reason why he believes the compressor has failed, the alarms that have been showing into the system. And by doing that, basically the technician generates a service ticket. We receive the ticket in advance prior to compressor receival in the company. When this is coming, we already know a lot of information about the history of the compressor. So if the customer is saying compressor is vibrating too much, what we do is basically to put this on a rig and test. If the customer is saying compressor is loud, same thing. If the customer says compressor is grounded, we first test the electric plate. This is based on information. So I am fully with you when you say we all need to learn and we need to be helped by service technician in understanding why the compressor has failed, and they know what happened in the field, at least the alarms, so we can make our mind and understand where to shoot, what to see, and what to check more in detail.
So do you recommend, so if a technician has a compressor that either has issues or failed, do you guys recommend them inspect it before they set back and fill this out? Do you have like in this?
No. If this is within the warranty period and they want to have a warranty recognition, compressor does not have to be opened on site. Okay. Because we are losing plenty of information about the root cause.
Yeah, because there's a process that you guys do to take apart. Because I even know I've done it before where you're taking the bolts off by their torque ratings. So you know exactly if they were torqued properly and steps like that.
Correct.
What is the timeline for that? Because I know right now, any compressors in North America, I'm assuming would have to go back to Florence and back to Italy. So there would be a time.
No, sir.
No.
We actually have already up and running our maintenance center in Tecumseh, Michigan.
Amazing. There we go.
Yeah. We have we have purchased the new industrial building in Tecumseh, where we are stocking 600 plus compressors and where we are able to do compressor tear down and inspection reports.
Perfect.
We are able to deliver on a 24/7 basis. We have 4 stocks in the US, 1 in Michigan, 1 in Tennessee, 1 in Nevada, and 1 in Oregon. And our inspection and repair center is in Michigan. So we are able to deliver compressors right away so that we do not let the customer down, not at all. And then with the needed time, we are able to produce a fully detailed report with pictures and movies of what we have been finding into the claimed compressor.
Awesome. And so who does that information go back to? Does that get back? Because I know there was when I worked at the manufacturer, sometimes the technician told me they didn't receive the report. So does the contractor themselves get the report? Does that go back to the manufacturer of the equipment? Or does it go back to a distributor that sells your compressor? Because there's a chain there, right? And sometimes I've seen it lost before where the technician pulls out the compressor, puts a new one in, sends it back for warranty, but never gets to see that report. So if you can't tear the compressor apart within that warranty period, what's the timeline that you guys try to get to the customer who sent it back?
Let's say when the compressor failure happens within the warranty period of the compressor, 100% of the time, the OEM is fully engaged in taking care of the issue because this is his delivery and his equipment. So they refer back to us, they send us the compressor for inspection, and we produce the report and we send it back to him, to the OEM.
Yeah, perfect. So this is good to know for all the technicians out there because you're doing the work, you're pulling the compressor out. If you do not get that report, you need to follow up with the manufacturer of the equipment. So key. You need to understand that because you need that report. You need to understand what caused the failure. You may have found a failure. Maybe it was flowback and you figured that out when you installed a new compressor, but you need to follow up to get that report. And hopefully you can work and build a relationship with the manufacturer of the refrigeration of the CO2 equipment and find that report. Awesome.
Right.
So impressive. I love that. And it's super cool that you guys have inspection sites here in North America to really help the people here.
We are investing a lot in North America, honestly, really.
I learned so much today. Every time I talk with you, I learn something, Giacomo.
Yeah, same for me. Same for me. So
I got a couple of questions here. I know we could go for another hour, but I got a couple of questions. Are all Dorin's splash lubricated on CO2 compressors? Do they have pumps? Do any of yours have pumps, I guess?
yes, transcritical compressors are available with oil pump starting from 10 horsepower and up. From 10 to 90 horsepower, 90 horsepower, transcritical compressor do have an oil pump. Smaller compressors do not. They are sling disc lubricated.
Awesome. I got another question. What about New Zealand, Australia in relation to compressors under warranty? Would the compressor need to go back to Italy from New Zealand or Australia?
New Zealand, Australia. Well, actually, we are building up some relationship with local remanufacturer, but honestly, as of today, we do not have an authorized repair center in Oceania. No.
Okay, good to know.
Closest one would be China. I know it's complicated, but that's the way it is.
Yeah, no, this is how you start though, right? As the business starts to grow and there's more availability and more want, the demand gets higher. That's how you build your business and continue to grow. And that's how you guys did it for the last 30 years. And you're continuing to grow and get bigger and just be out there. And this is why you're making a big play in North American market now, which is awesome. I love this. Learned so much today. I got a pile of notes here. Hopefully a lot of you've taken notes today on this. How can people reach out to you, Giacomo, or find out more about Dorin?
Yeah, I'm just typing my email address in the chat box. Don't be shy. I am available.
Yeah,
so,
awesome.
g.pisano@dorin.eu. Very happy to support.
Thank you so much for taking the time. Thanks everyone for hanging out with us for the last 45 minutes, hour. Really appreciate it. This is what it's all about. Sharing CO2 knowledge, learning from the experts just like Giacomo. And I can't wait to see everyone at the next CO2 Monday. Thank you so much again, Giacomo. Thanks everyone.
Thanks a lot, Trevor. All the best.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.